Hello students, सभी को नमस्कार. Myself Mukesh Sitpal, Assistant Professor, School of Agriculture, ITM University, Gwalior. So today I am going to discuss the differentiation of function. This is the topic of unit second, and this is the lecture number 10. Okay. So in this lecture we will discuss the differentiation of function, chain rule, subsequential method, numerical problems on chain rule, numerical problems on subsequential method, and some assignment problems. So suppose we have given a function 2x minus 1 to the power 3 and we have to differentiate it. The differentiation of 2x minus 1 is very simple, but when its power becomes 3, then it is not possible to differentiate it by the use of the formulas that we know, because this is a quadratic function because its power is 3, and the function 2x minus 1 is a linear function. It can be differentiated, but when its power is 3, so it is a cubic function, so that will not be differentiated. So this is a cubic function also and a linear function also. So we have to, this is a function of function. Okay, so this is a function of function. So like we see some other examples like x square minus 3, that is a quadratic function, but when its power is 3, so it is also a cubic function. X plus 1 1 plus x to the power 4 is a quadratic function, but its power, when it is under roots, so it is a square root function also. So for those types of problem, we have two ways to differentiate these function of functions. One is chain rule. So what is chain rule? So suppose we have given y, which is a function of x. So the function of a complicated expression. So you have to assume that this complicated expression as u. Okay. Then you have to work out two exercises. Firstly, you have to find dy by du and du upon dx. And in chain rule, if we want to find the dy by dx, then we have to find the dy by du and du upon dx. Then we have to find the product of this. By this formula, we can differentiate the function of function. So we see some examples on this topic, that is chain rule. Okay. So suppose we have given y is equal to 2 minus x to the power 3 and its power is 4. So in this case we have to assume this 2 minus x to the power 3 as u. Now your function y becomes y is equal to this 2 minus x to the power 3 is assumed as u and its power is 4. So this function is equal to u to the power 4. Then we have to find dy by du. So we have to differentiate this y with respect to u. When we differentiate this function with respect to u, so this function becomes nx to the power n minus 1. So this 4 power comes in the front side and u to the power 4 minus 1, that is 3. Then the second thing, du upon dx. So the u that you have assumed you have to differentiate this with respect to x. So 2 is a constant, its differentiation will be 0, this minus, so we write here this minus, and differentiation of x to the power 3 is 3x square. Now the formula of differentiation dy by dx is dy by du, that is what this, into du upon dx, that is what this. So we have to multiply both of these here, and 4 3s are 12, because it is minus 3, so it is minus 12 x square, so we write here x square, then u to the power 3. So what is u? U is your 2 minus x to the power 3, so we write here 2 minus x to the power 3, and its power is 3, because u to the power 3 is there. So we have put the value of u in place of u. So this is a simple question. Now we will see another question on this topic. You have given y is equal to x, yx is equal to 1 upon 1 minus x square. So y, so we write here this y is equal to, so when its power is 1, when it goes to the numerator, its power will be minus 1. Okay. So we assume 1 minus x square as u. So to find du upon dx, we have to find du upon dx. We have to differentiate this with respect to x. So differentiation of 1 is 0, and this is minus, so we write here minus x to the power 2. So differentiation of x square is 2x. Okay, so this is y is equal to, and we have assumed that 1 minus x square is u, so it becomes u to the power minus 1. So we write here, then dy by du, so nx to the power n minus 1, this is the formula. So minus 1 into u to the power minus 1 minus 1, so that will be minus 2. So minus 1, so that power that is in minus, when it goes to the denominator, so its power will be positive. So this is your answer. So for this type of function we have to solve this one first, then we have to find dy by dx, then we multiply both of these. So we write dy by dx is equal to this minus 2x into this minus 1 upon u square. This minus and this minus becomes plus, and this 2x is multiplied with 1, that is 2x, and what is in denominator, that is u to the power u2 square, u square. So what is u? U is your this 1 minus x square, so we write here 1 minus x square, and its power is 2, so we write here its power is 2. So this is your final answer of this question. Now the second method, that is a sequential step method. So this method sometimes similar with the previous one, chain rule, but this method is simple as compared to previous one. So in this case we start from the outermost function and differentiate toward the center one. How this method applies, I will show you example. That suppose you have given y is equal to 2 minus x to the power 3 and its power is 4. Okay, so what we will do, because its power is 4, so we write this power, when we find dy by dx, so we write its power 4 in front, then this whole expression, and x to the power n is nx to the power n minus 1. So what is n here? That is 4, so we write 4 here, and x to the power n minus 1, 4 minus 1, that is 3. And this is your expression that is written here. So what we will do, we write 4 and this expression, its power is 4 minus 1, that is 3. Then again we have to differentiate this function 2 minus x to the power 3. The differentiation of 2 is 0 and this minus, so we write this minus x to the power 3. The differentiation of x to the power 3 is 3x square. Now we multiply the things. This 4 is multiplied with this minus 3, so it becomes minus 12 x square and 2 minus x to the power 3 whole to the power 3. So this is your final answer of this question. Then we see the previous question, y is equal to 1 upon 1 minus x square. Its power is 1. Okay, so when it goes to the numerator, its power will be minus 1. By simple we will do this by second method. So we write this minus 1 power here in the front side, minus 1 into this whole function and its power nx to the power n minus 1. Minus 1 minus 1, so that will be minus 2. Then the inside function we have to differentiate it. Differentiation of 1 is 0 and this minus, so we write this minus, and the differentiation of x square is 2x. So we will multiply this minus 2 with this minus, so this becomes 2x, and when this minus 2 goes to the denominator, it will be 1 minus x square to the whole square, because when it goes to the denominator, power will be positive. Suppose we have given this question y is equal to this, so because it is under root, so we can write its power is 1 by 2. So we write x square minus 1 here and its power is 1 by 2 because of this square root. Now what we'll do, we assume it as x to the power n. The differentiation of x to the power n is nx to the power n minus 1. So this is your n, so we write here 1 by 2 and this whole x, its power 1 by 2 minus 1, and 1 by 2 is subtracted from 1, so what will be remain, that is minus 1 by 2. Then we have to differentiate the inner one. Differentiation of x square is 2x and differentiation of 1 is 0. So when this 2 is cancelled with this 2, so what remains, that is only x, and in bracket x square minus, sorry, what is remain only, that is x in the numerator, and when this whole things goes to the denominator, its power will be positive. So its power is 1 by 2, so due to that it will be in square root. So this will be the final answer of this question. Similarly, we can do this one exercise also. We have given y is equal to sine log. Okay, so firstly we assume this whole thing as theta. Differentiation of sine theta is cos theta. So we write cos and whole this function. Okay, then it goes to the inside. This is log and this is x. We assume this whole as x. So log x, differentiation of log x is 1 upon x. So we write here 1 upon x. X is your this one. Okay. Now the center one we have to differentiate it. That is 3, and differentiation of x square is 2x. So 3 into 2x will be 6x, and the differentiation of this 2 will be 0. So we have to multiply all these things to get the final answer. So this is your final answer of the question. There are some exponential functions also there for the function of function, like we have given y is equal to e to the power bx. We know the differentiation of e to the power x, but we don't know the differentiation of e to the power bx. So how can we solve? Suppose you have given y is equal to e to the power 2x square minus 1. So we don't have any formula to differentiate this one. So we can solve this type of problem by function of function. So suppose you have given y is equal to 5 e to the power x. So this y will be differentiated and written as dy by dx. And we write this 5 here, and differentiation of e to the power x is e to the power x. Then question number second, you have given y is equal to 3 e to the power x plus 2. So we write dy by dx, we write this 3, and differentiation of e to the power x is e to the power x, and differentiation of 2 is 0. So this is your final answer of the question. Here you have given y is equal to e to the power bx. So we have to assume bx is equal to u. So your function becomes e to the power u. So you have to apply the chain rule here. Firstly, we have to calculate dy by du, then du upon dx. So dy by du will be the differentiation of e to the power u with respect to u is e to the power u. Then the u that you have measured, that you have assumed, dy by dx, du upon dx. So differentiation of x with respect to x is 1. 1 is multiplied with this b, that is your b. So du upon dx is your b, and dy upon du is your e to the power u. E to the power u. U means bx. This is your bx. So we put the values of e to the power x, e to the power u. Okay. So this will be e to the power u into b. Okay. So we write b in the front side, and e to the power u. The value of u is bx. So we write here bx. So by this way we can solve these types of questions. So these are some problems also given here. So you can solve these types of problems by using these rules. So these are some assignment problems that is given to you for your homework that you have to solve. I solve a small question that you have given y is equal to x into e to the power minus bx. So this is the product of two functions. First function is your x, and second function is your e to the power minus bx. Okay. So what is the formula? First function, that is your x, into differentiation of second function. Second function is your e to the power minus bx. So differentiation of e to the power minus bx can be calculated by as the problem that I have explained. So we have to firstly write e to the power minus bx, and we have to differentiate e to the power minus bx. So we write minus b front side, and differentiation of x with respect to x is 1. So its whole differentiation will be minus b into e to the power minus bx, then plus second function, that is your e to the power minus bx, into differentiation of first function, that is x. Differentiation of x with respect to x is 1. Now we have taken e to the power minus bx as common. So what remains here? Only 1 that we write here, and this is minus b. So we write here minus bx, minus b this, and x minus bx, and e to the power minus bx is taken outside. So this will be the final answer of the question. So I think you understand the things, and if you have any doubts after this lecture, you can contact me. So thank you so much.